Alright, let's get started. So, in this series we're going to be constructing this miniature steam engine you see here with each individual component beginning to end. We'll be using Solidworks. I'm using the 2015 edition. We'll be building this model based on these drawings, which you can find at inventorwizard.com underneath their blueprint section, and this one is called their miniature steam engine. So as I said, we're going to go through here building each individual part one at a time, and then by the end of the series we will assemble this the main assembly here, and we will have a completed model, and it will be fully functioning. All the parts will move and everything, and we might even look into doing some motion analysis with that at the end. So let's get started. The first part we're going to do, sorry, this is going to have to start off rather elementary. This is the first one that we'd have to do. So all the parts are named, and these, let me just say, the blueprints from this from inventorwizard.com are very well made. They're very detailed. All of the dimensions are there. I've built several things from their library already, and I haven't done this one yet though, so this will be the first time I've done any of this. Let me show you some of the stuff from their other library real quick. So this is their little six-cylinder pneumatic engine. It's got a flywheel here. You can see the 6 cylinders, and this is a very, very detailed model. Let me just give you a cutaway real quick of it. Here's the inside. As you can see, this model is complete with all the cylinders, cylinder heads, the bolts, and the nuts going through the cylinder. All the connecting rods connecting each of the pistons to the connecting hub here, as well as even the counterweight on the drive shaft. And as you can see, it all works, completely functioning. I do have some motion analysis of this this little steam engine done. If you'll give me a moment, I'll see if I can pull that up. There it is. As you can see, it works. It's completely functioning. All the parts move. And if we were to flip this around, you can even see it. The flywheel turns with the piston. So it's a very, very detailed model. So that's what we have to look forward to. This is one of their more simple models. This one only took a couple of days to do. This other one, which is their model steam engine, or miniature steam engine, my bad, is far more complex, and I'm sure it will give us plenty to do. So let's get started. Like I said, we're going to start off rather simple, so bear with me. I promise we will get to some of the more interesting components of this part, such as that right there. That is the base for the steam engine. So without further ado, let's get started. Alright, and so we're going to get a new part here. If any of you are following along with the blueprints, actually I will provide a link to the blueprints in the description of this video. So if you want to go and get those blueprints, then you may. I think it will help you to be able to follow along as we are going through each of these individual parts. Give me just one moment, let me look that up. Alright, there it is. So, the first part that we were doing, and if you'll look at the blueprints, they're organized to where the first 6 or so drawings are, hold up, my bad, the first 5 drawings are of assemblies. So we want to skip over those, and we first want to make the parts in order to make these assemblies. So the first part that we come across is the vertical twin steam engine with reverse gear lower base bearing holder. So that's this guy right here. So we'll go ahead and get going on that. We're going to start a new sketch on the front plane. Oh, and another thing, let me point out real quick before we get going. Make sure that your units down here are in millimeters, grams, and seconds. That the MMGS. Those are the units that we will be using for this model, and that those are the units that they use in the blueprints for the model. So let's get going. Going to draw I'm going to sketch a rectangle on the front plane. I'm going to set its dimensions to the dimensions shown on the drawings. That is 11.5 millimeters tall by 24 millimeters wide. Alright, and there is, as you can see, there is a half of a cylinder going cut through the top part of the part, and that cylinder has a diameter of 12 millimeters and is from the center of the top. So we'll just draw a circle here. Make that 12 millimeters in diameter. And then we'll come and we'll just trim out this top portion. So now we have the cross-sectional view of the part, and according to the drawings, the part is 18 millimeters in depth. So we'll just do an extrude, a boss extrude of that sketch, and now we have this part. And just to go ahead and get everything accurate to the drawing, if you look over here, so the part looks right. If you'll notice down here in the bottom right, they give us a material section. It tells us that it is made of soft yellow brass. So come up here to our materials, right click that, click edit material, and what we're going to have to do is we're going to have to look through. It will most likely be under, it might be under copper alloys. No, it will probably be under other metals. So if we come under other metals, actually I don't see it. I might have to look up and see if brass comes in the Solidworks material list to begin with, because these drawings are actually from assemblies which are made in Autodesk Inventor, my bad. Autodesk Inventor. So I don't know if Solidworks includes brass as one of its initial, oh, yep, there it is, my bad. So I'm going to click on brass and click apply and close. So there, now our part is accurate in terms of materials and sizing. So there you go. Alright, and now that we have that part down, so I'm going to go ahead and save this. I'm going to create a new folder here for the miniature steam engine. Alright, and let's go ahead and name this the name of the part in the drawings, which is lower base bearing holder, and save that as a part. So now we're done with that one. We will move on to the next part, which looks very similar. This is the base bearing lower holder 2. So looks like the same part, 24 by 11.5 millimeters, 12 millimeter diameter hole cut through the top half of it. And the only difference is the amount which it is extruded. So to make things a little quicker, what I will actually do is go and open up this part that we just made, because it's the same dimensions except for the extrude, and click save as, and I'm going to save this as a new part with the name of the second part. So that was base bearing holder 2. So now that I have this saved, what I'm going to do, I'm going to change this extrude to make it 38 millimeters long, which is the depth of the new part. So as you can see, there it is, there it is. So now that is saved, we'll close out of there. Now moving on to the next part, now we get to do some more intricate designing here. So as you can see, hold up just 1 second. Alright, give me 1 second, please. I have to check on something. Alright, so, as you can see, this part is a little more intricate. We have a series of different extruded cuts which go through. We have that same half cylinder cut through the bottom half. We have a couple of holes, and these holes are filled as well. So we have some new dimensioning here. Obviously, the circle with slash through it shows diameter. These show the depth and the angle at which chamfers are made, and the way that you will know the difference between whether or not it's a chamfer or a fillet. With fillets, they will actually give you radius measures. Let me see if I can find a part real quick with a fillet instead of a chamfer, and I will show you. If not, then oh well. Yeah, I'll just have to show you later whenever we come upon a part that has it. But for now, most of what we do will be chamfers, and that's signified by the depth and the angle at which that chamfer sits. So let's move on and get to this next part that we have. So this one, for those of you following along the blueprints, just to make sure you're on the right part, this is called the upper base bearing holder. So let's get started on this. Alright, and the way we are going to do this, it's going to be very similar to what we have done in the last few parts, just a few more features and dimensions we have to add in. So we're going to start with a sketch on the front plane. I'm just going to get the main body of the part drawn out. So it's 66 millimeters wide overall. And for now, I'm just going to model the bottom half, and I'm going to extrude the top half up off of this bottom half, so it's 8 millimeters thick. Actually, while in this drawing, I will go ahead and make sure that I get that second half up there on the top. Alright, let's see. So the second half on the top is going to be 24 millimeters wide, and it's going to be 6 millimeters deep. Alright, and just to make sure that we get these centered, let's just go ahead and say that is 12 from the edge. There we go, got that centered up. That's going to be all one extrude, so we can go ahead, trim that. If you look at the part, it has some chamfers on these top two corners, and we can actually go ahead and take care of those chamfers. Now that I look at it, this is actually 7.5 millimeters, so we'll change that real quick. Alright, so we can go ahead and take care of those chamfers in the sketch instead of having to add them to the feature later. And we see that those chamfers are 2 millimeters deep by 45 degrees. So what we're going to do is we're going to come up here to the Sketch Chamfer tool. We'll click on these two. Oh, first change the distance, or else Solidworks won't recognize that corner as an available chamfer. So we're going to change those each to 2 millimeters. Now, because it's 45 degree chamfer, we don't have to change it to angle distance, because by default distance with equal distance makes a 45 degree chamfer. So all we have to set is the depth of that chamfer. We're going to click check there, and that made your 2 chamfers in your sketch. So the next thing which we are going to do is we're going to create a 24, yep. So as you can see, this has got an indentation coming off the bottom of it right there. So we're going to model that next. So what we will do is we'll take, this is going to be lined up with the rectangle over it actually, because they're both 24 millimeters wide. But we will go ahead and double check that and make sure that that is fully defined. So this is going to be 24 millimeters wide. Alright, and actually, if you'll notice, there's a 45-degree angle coming off the edge of these, and we actually can't do a chamfer with those because that would chamfer from this edge in. So, and that 24 millimeters, as you can see, is done from the inside to inside of the chamfers. So there are two ways we can do this. We can either do a sketch off of the corner here at 45 degrees, or we can make this wider to account for the chamfers and then chamfer the edges. So I think we're going to go with the second option. So because this is 1/2 of a millimeter thick and is a 45-degree chamfer, we know each of these have to be 1/2 millimeter wide. So with each of these being 1/2 millimeter wide, that means we need to add 1 millimeter to account for both sides to the width, which also means that we need to go and recenter this. So this needs to be 12.5 now because it's 1/2 of 25 millimeters. So now that we have that, we can go and we can do a sketch chamfer, and we make that chamfer 1/2 of a millimeter. We can go and click these two corners. Okay, my bad. We need to trim the sketch entity here first. Alright, so if we will go do a sketch chamfer, and oh, my bad, it looks like we can't actually do a chamfer there because it will completely delete this line. So instead, we are going to go ahead and do it. The first suggestion was we're going to create a line down which is at 45 degrees. What's really nice about Solidworks is it will snap to those degree measures of 90 and 45. So if you watch it, there it goes, it snaps to 45 degrees. So we're going to draw those two angles in there and trim these two entities. So we now have that little indentation on the bottom. So this is looking pretty accurate so far, if you look here. So all we really need to do now, looking from the side, these holes actually don't go all the way through like that. They're actually in the center of the part, so we don't need to worry about those for now. The only other thing we need to worry about is this semicircle cut through the bottom. So we're going to do that the same way we did the last one. We're going to come to a center, draw a circle, just smart dimension that to be 12 millimeters, and use the trim entities tool to trim off these two bottom edges. That way we can extrude through there. So now this part is done from the front, we'll exit out of there and we'll pull back up our drawings, and we can see that it is 18 millimeters thick. So what we will do is come up here to features, extrude ball space, do that out to 18 millimeters thick, and there's the part so far. And just to go ahead and take care of it, we will change this to brass. There it is. Alright, now the last thing we need to do is create the 3 holes which are in the top of the piece. So we're going to, and I believe all 3 of those holes go all the way through, so we're going to start a sketch on the top of this piece. We're going to take first, and we're going to draw circle the center, and that circle is 6 millimeters wide, and it's also in the center. Because this part was 18, we'll just smart dimension this from the edge to be 9 millimeters. Alright, and next we need 2 matching circles on either side here. We'll just draw these 2. We could mirror the sketch. Well, my bad. We could mirror the sketch, but for the sake of it only being 2 circles, we will just draw each of the individual circles. And these are each 6.5 millimeters in diameter, and according to the drawings, they are 45 millimeters apart and centered, which means that they should be 22.5 from that center circle. If you see here, you can smart dimension this to 45, it centers everything up. So let's go ahead and do an extruded cut using that sketch, and we'll just say through all because it goes through the entire part in all 3 of those circles. Alright, good. Now we have our circles, our holes through a part. Sorry about that. Sorry, I had to take care of some college stuff. Alright, so as I was saying, the last thing we need to do on these, on this part is to, oh, my bad, let me get back down to our part, is to create the fillets on the edge of these holes. And like I said earlier, this is signified by the depth of the, chamfer, my bad, the depth of the chamfer and the angle of the chamfer. So as we can see, the chamfers on these two holes right here are 0.25 millimeters deep and at 45-degree angles. So if we come here, have a chamfer there and there. That's obviously way too much, so let's change that to 0.25 and at 45 degrees. Go ahead and click check on those. Alright, that's looking good. And the last thing which we need to do, if you will look, there are no dimensions for the chamfer on this hole in the center, and that is because that hole is threaded and it is an automatically generated fillet, chamfer done by inventor whenever a user assigns a hole to be used for a specific type of screw. And as you can see, the threads are also shown in there as well. So those threads are only aesthetic. They're not actually used in any way, shape, or form by the model, but I will go ahead and show you how to insert some of these cosmetic threads. So what we're going to do is we're going to come up here to insert. If you go down to annotations, there is a cosmetic thread option, and if you will click on that and choose the end of the hole or the end of the cylinder which you want to have for the threads, it's called circular edge here in Solidworks. We'll just go ahead and select this one, and if you will choose the system under which the thread type will be, it will be machine threads, and this is a 6mm hole, so we're going to look for the M6 option, which there actually doesn't appear to be, interestingly enough. Let me make sure that I made that the right dimensions. Yes, that's a 6mm hole. Well, that is interesting. I will have to look into that. Oh, my bad. I actually need to make that 5.5 millimeters. The reason being is that in order to make the threads onto a cylindrical body, you must have a hole smaller than the threads themselves, and it appears that that was not actually enough. Let me just get rid of that. Maybe it has to be, I believe it has to be, it was either 0.5 millimeter or 1 millimeter smaller than the thread size. So this should work now. If we go to Insert Annotations, Cosmetic Threads, choose this as our endpoint. As you can see now we have a M6x1 option. So if you choose that under Antimetric Machine Threads, and if you just do, we'll do through all because these threads go all the way through, and go ahead and check that. You notice no threads appear here. You can actually click on this line, and that's your cosmetic thread indication there. The way which we have to get these cosmetic threads to appear is to go, I believe, to should be under you have to change the document preferences, which should be under Tools, Options, and Document Preferences. If you go to Model Display, Annotations, should be under here somewhere. Oh, Detailing. My bad. If you go and check the Shaded Cosmetic Threads option, click OK. Now, as you can see, we have threads in our model. And what we're going to want to do is we have to insert that chamfer manually, and that is a 0.5 millimeter chamfer. The way that you can tell how large this chamfer should be is the circle indicating your cosmetic threads. You need that chamfer to meet that circle, like so. So now that we have our cosmetic threads done, let me turn off the annotations real quick. So now you can see that that fillet matches the fillet in this part here. So I believe we're done with that part now. So we can save that part. It's called the upper base bearing holder. We will save that one. So that is our third part in this project. So let's look at the next one. Yeah, this next one, just like with the two parts before, is the same as the last part, just a deeper extrude on the part. As you can see, all the dimensions are the same: 66 millimeters wide, 8, 7.5, 14, just like this top one, a 12 millimeter hole through the middle, 24 millimeter indentation off the bottom, and the two 6.5 millimeter holes on either side with the M6 screw down the middle. So we're going to use the same strategy which we used on the last set of parts, and we're going to open this part that we just created, click Save As, and we are going to name this just like the name on the next part, which is Base Bearing Holder 2, Base Bearing Upper Holder 2. So we're going to save that under that new name, go to our boss extrude, and we're going to make that out to 38 millimeters instead of the 18. So as you notice, there are a few things we need to go and change, such as this sketch here. Instead of 9 millimeters, this now needs to be half of 38, which is 19 millimeters, to put those into the center. And as you see, it kept all our chamfers, it kept our cosmetic threads as well, as you can see by that dimension. So this part is also done. Let's click Save and close out of there. Alright, I believe that's all we're going to do in this segment, but next time we will be starting on this part, which is the base for the miniature steam engine. And this part will probably take up all of next episode. If not, we'll only do a couple more of these simple parts. But yeah, that's what you have to look forward to. Thank you for watching this first section of this project, and I look forward to completing this model over the coming few weeks. Thank you.